this session basically is about integration. When we talk about the integration, I thought about three things. You know, you think about the high-speed train running from Nevada to California, and you want the train making the transition smoothly. You want the gauge to be the same. You want the signal to be the same. You know, so this, at least the signal system should be the same. That is one thing. Another thing is that we all know that, you know, one day I asked my students to look at all our proposed high-speed rail corridor to see how many of them having, you know, having passenger high-speed rail running on the freight track. So they found that there are like 70% of this corridor running on the existing freight track. That is one thing. Another thing is that you can think about those terminals, for example, in California, in San Francisco, or Los Angeles. You may build a new station only for high-speed rail, or you have the high-speed train track in an existing terminal. You share together, and so there's all about the technical, you know, compatibility and also the political coordination. So that is all about this session. So design and operational integration of a high-speed rail. We have a great moderator, Mr. Jeff Morales. He is the CEO of California High-Speed Rail Authority. So I'll turn this into you. Thank you.
Thank you. Thank you, and thank you all for being here and sticking it out on a Sunday. So those of you who know me and have worked with me might be wondering why in the world I would be on a panel talking about designing things, but I'm actually overseeing that now, so there is a role. But Dan Richard gave a great overview this morning of where we are with our program overall, so I'm not going to rehash any of that, but a few points that lead into this panel discussion. Over the course of the last year, we've gone through some significant changes with the California High-Speed Rail program. Some of those changes, in fact, allowed us to move forward. One of the key elements, one of the very most important changes, was looking at how to integrate high-speed rail into the state's rail network and overall transportation network. That decision and that recognition of the importance of integrating created tremendous opportunities, not the least of which was allowing legislators to feel more comfortable about taking the plunge and voting to move forward with the funding for the program. But it also brings with it some challenges, which we'll talk about, how to integrate different types of technologies, different speeds, all those types of things. And when it comes to design, we are designing our system today. We're ready to move out. We have our, as Dan mentioned earlier today, we actually have our first bids for our first major design build contract due next Friday. And we will be awarding a contract by the summer. So from the time that the California legislature voted to approve funding, we will be within 1 year underway with the country's biggest infrastructure program, something we're very proud of and very pleased about. Thank you. Mort Downey made a point this morning which struck me very directly, which was it's great to be like the third, fourth, or fifth project to take advantage of what the first few did. Good news is we're first, the bad news is we're first, I guess, in that respect. So we will be the proving grounds in many ways for many of the issues that will be talked about by this panel. And frankly, the high-speed rail is different than virtually anything else in the country as far as transportation infrastructure, certainly. And we're seeing that even in the environmental phases where, for instance, both California's state environmental and the national NEPA weren't prepared to deal with 500-mile-long projects. So we're breaking ground on that front, everything relating to design, to financing the project, and to operations. Our goal is to get as much of that right as possible, obviously, in the outset, and move forward as effectively as possible. And so the perspective of people like those on this panel is really critical to us as we go forward, and I think to anyone as they move forward with the high-speed rail program. So let me introduce quickly our panelists, and then I'll go back and have them make their presentations, starting with Stan Feinsod, who I knew Stan when he was at New Jersey Transit, and I was working for Senator Lautenberg many years ago. Stan's a passenger rail consultant and managing director of RDMT. He's also the co-chair of APTA's High-Speed Rail Commuter Rail Joint Legislative Committee. Today he's going to talk about the importance and the quality of connectivity of different projects between high-speed rail and other modes. Next we have Brian Jenkins, who's director of the National Transportation Security Center at the Mineta Institute. Brian is someone you probably recognize from TV. He's one of the go-to people for the networks when there are ever certainly transportation-related security issues. He's truly a world expert. Brian is a former captain with the Green Berets and started Mineta's Transportation Security Research Program. I got the chance to know him. He was on the White House Commission on Aviation Safety and Security. It was a really vital piece of that. At the time, I was working for Vice President Gore, who was chair of the committee, and I got to know Brian and his good work there. Next to him, we have Armin Kick, who is Director of High-Speed Rail Development for Siemens, and I'm pleased to say located in California. So that's good. And he's responsible for high-speed rail development for the company throughout the U.S. He's also worked as a rail consultant and brings experience from Europe, and some of what he will talk about is that European experience and how it translates into the U.S. So with that, let's begin, and I'd like Stan, if you could go ahead and start.
Thank you, Jeff. I don't know if Dan Richard is still in the room, but Dan, I also came from New York. And I have been in California for 16 years, and now I think I'm being accepted as a pre-citizen of California. Another 15, 20 years, I might be able to take the test and pass it. I also want to make another comment about education. There's been a lot of mention of the Mineta Transportation Institute. It's a transportation management program, lots of research, but also at its core, it's about teaching people who are looking to advance their careers in transportation management. And I teach a course. There are 13 people in the course. They're diverse, from young college age to people who are looking to change their careers. And they're learning how to be transportation managers. So in response to some of the challenges of the last panel, yes, there are some programs. They're represented in this room from University of Nevada at Las Vegas, the University of Illinois, from the school that I teach at. So there are programs underway. Today I will make some general remarks about the importance of connectivity as we plan and implement high-speed and intercity passenger rail service improvements, and describe a research project being initiated by the Mineta Transportation Institute at the Lucas Graduate School of Business at San Jose State University. Connectivity refers to the linkages between the station and the urban transportation system serving the city. We are concerned with the establishment, maintenance, and quality of the connections between intercity services and the local services that are available or should be available at every station. Although concern for connectivity seems obvious, connectivity is not always provided, and the quality of connections is often less than it can be. Considerations for connectivity must be part of the earliest planning process for improved intercity services, and often involves complex institutional arrangements among service providers and complex physical planning to create convenient transfers. Most importantly, connectivity must be seen from the perspective of the customer, who is interested in traveling between an origin and a destination using high-speed and intercity passenger rail services to make the backbone part of the trip. But passengers are also concerned with getting to and from terminal stations. High-speed and intercity passenger railroad stations are gateways to their surroundings. By providing convenient connecting services, the reach of the transportation system is increased to the environs surrounding the station. Ridership is measurably increased when information about connections is available, defining the intercity service in part by its feeder services and services permitting access to a broad destination area. Consideration must be given to linkages to local taxi, paratransit, bus, and rail services located conveniently within and just outside the terminal station to permit transfers. The quality of connectivity is in part determined by the information provided to passengers with respect to the services available, the locations that can be reached using those services, the location and physical design of the transfer points within the station and just outside it, and lastly, how fares can be paid to actually board and use the services. Information can be delivered with graphics, signage, easily found maps, information agents at the stations, and using web-based and communication-based applications, delivering real-time information to customers with smartphones. Quality is also determined by the physical design of the connections, the convenience of actually moving through a station to a connecting service. How far do passengers have to walk? Are there ramps? Are escalators and elevators available if a level change is needed? Is the path ADA accessible? Is the path well marked? Planning for new and improved high-speed and intercity passenger rail services must consider connecting service availability as early as possible. Relationships to local service providers need to be enhanced and improved connections discussed and implemented. This requires an extra effort to reach out to local transit, paratransit, taxi providers to discuss connection arrangements and improvements that could be planned before initiation of a new intercity service. In some cases, high-quality connectivity may require changes to bus routes, complex schedule coordination, agreements for physical access to station areas for convenient boarding, new ticketing arrangements, space for signage, public announcements, space for driver comfort stops, design considerations for AD access and accessible paths, etc. Passengers should expect information to be available on how to use local transportation services and how to access intercity service, how to leave their destination station to get to their final destination. That says 6, right? Good. This requires a high level of planning for connectivity. In California, we have 3 intercity services that are beautifully designed with access and egress bus services. This is a great example of connectivity. We are trying to attack confusion. Sometimes I think that public transportation's biggest product is confusion. Where am I? How can I get to where I want to go? Where does this staircase go? And one of the most difficult things to achieve in connectivity is connectivity to bus services. We seem to have a great deal of trouble explaining where bus routes go and how they can be found and how to pay for them. Better graphics, improved schedule coordination, and information on arrivals of the next vehicle is needed. Another difficult issue is how to move passengers from their arriving mode to a connecting service is how to deal with fares as barriers. We need to give attention to integrated fare systems and the removal of that barrier. I want to turn quickly to the project we are initiating at MTI. It's a FTA-funded connectivity study to develop standards for connectivity to different size urban areas. We have two objectives. First, to establish those standards, and second, to energize the 26 stations in California, the urban areas, 3 minutes, to improve the connections and connectivity to their urban systems. We're going to do a web-based bibliographical review. The research will identify existing conditions and attempt to find worldwide a set of examples that can be translated into standards. And then we're going to talk to 3 of the 26 areas, talk to the metropolitan planning organizations and the transit service providers, and try to apply the standards to their systems and help energize their search for improved connections. The research team will use a standard survey instrument and use in-person interviews with metropolitan area and transit agency leadership in those 3 case studies, communities. You had me going there. Well, we're going to be on time. She just showed me 0. I will interpret it as 0. The objective of our work is to complete it in the fall. Thank you for your attention.
Thanks, Dan, and thank you for not getting your wrist slapped, I guess. So, Brian?
Thank you very much. I've been asked to talk about the security issues in design. Jeff Morales mentioned that he and I had the privilege of working together on the Aviation Safety and Security Commission about 15, 16 years ago. That doesn't mean I'm going to suggest anything like an aviation model of security for high-speed rail. But one of the lessons that was underscored in the Commission is that when we designed our airports, when we expanded our commercial aviation system, it was without thinking about the issue of security. The issue of security came along later, and so we have spent the last 40 years retrofitting and upgrading security. We have an opportunity now that we are designing high-speed rail for the United States to really address security issues as part of the design, as part of our planning in advance, instead of the very, very difficult way of going back and trying to put things in later on. I just must remark that Stan Feinstein said that talked about connectivity. Connectivity really does have implications for security, how we connect these systems, and we should connect them. But I mean, we do have situations like Penn Station in New York, where Acela, a high-speed system, comes into Penn Station, connects with other Amtrak trains, with local transportation. There are in Penn Station armed police or guards from New York Police Department Transit, from MTA, from New Jersey Railroad, Amtrak, TSA Viper teams, Port Authority Police, in addition to National Guard. We have 7 armed forces in Penn Station. That may not be the best way to do it. Let me go through these very, very quickly, and these should be available to all of you, so if I don't touch on everything here, not a problem. Our focus really here is why might terrorists target high-speed rail? What's the attraction? Do their attacks on high-speed rail differ from attacks on non-high-speed rail? And we looked at accident data mainly because we wanted to see what can accident data tell us about the possible consequences of successful terrorist attacks. Now, the accident data is also interesting in itself, and there's really good news here. We took a look at The high-speed rail systems operating in 12 countries. I don't want to claim that our data is absolutely complete. We certainly captured the major incidents. And then we looked at the Mineta Transportation Institute's own database of what is now approaching 3,300 terrorist attacks on public surface transportation, and we reviewed those attacks that took place on high-speed rail and compared them with non-high-speed rail. The first conclusion, as I say, is certainly a positive one. High-speed rail is safe. High-speed rail operating in 12 countries, a total of 218 years of operational history here in these countries. In that total, a total of 73 accidents with 172 fatalities. Now that works out to really a fatal accident every 13 operating years and less than one fatality per operating year. Now that's an extraordinary positive record. When we look at the fatalities, we find that of 73 incidents, 17 of them had fatalities. Now that includes 3 suicides, people jumping off of high-speed trains. It includes 7 motorists or automobile passengers who were struck at grade crossings. We didn't include, by the way, pedestrians killed on the tracks in the analysis. That's a problem both with high-speed and non-high-speed rail, people wandering onto the tracks. Of these 172 fatalities, what really drives the number there is 101 of them occurred in a single incident in Germany, a terrible derailment of a high-speed train that then ran into abutments and had other kinds of problems. If we take a closer look at those 17 accidents that had fatalities, the most common events are collisions at grade crossings. So first lesson for people designing these systems is grade crossings are a danger point that accounts for 9 events. It resulted in 2 derailments. It resulted in a total of 9 fatalities, although 7 of those were in the vehicles. The most lethal events are derailments. That was 7 events, resulting in 155 fatalities, but 2 events really drive those, 101 in Germany and what is reported as 40, although there are various numbers reported in a recent incident in China. The worst cases are the derailments involving collisions with another train or with abutments. High-speed rail has a lot of built-in security. It is often a separate right-of-way, often fenced, easier to patrol. The high speed of trains themselves makes timing, if one is in the business of attempting to time explosive devices for derailment, is a lot more difficult. There are some passenger and luggage screening measures in place or possibilities to do so, but now this begins to create really a policy dilemma and a design dilemma for us. So long as high-speed rail is confined to long-distance point-to-point, Eurostar, get on a train in London and get off the train in Paris, then security measures can be easily implemented. The more high-speed rail comes to look like an Excella, that is a longer 100 to 200-mile commuter train with more stops, high volumes of passengers, then that poses some security challenge. Now, the other thing that's very interesting about this is that both the construction of the rail and the construction of the carriages has some built-in safety and security measures. For example, the rigid coupling of high-speed trains means that when they do derail, they don't generally jackknife and do all of the things that non-high-speed rail do. They go off as a unit and tend to stay upright. We don't know that terrorists do this kind of detailed operational analysis of this, but they have some notions about this. So we ask ourselves the questions: how might terrorists view attacks on high-speed rail? Certainly, it's an iconic or prestige target. It's got a more elite passenger load, but it offers a lower body count than operationally easier bombs aboard crowded subways or commuter trains or in busy stations. And so for terrorists bent upon body count, the kind of attacks that we've seen in London, for example, or in a commuter train in Madrid, is the preferred action. They do see derailment as a potential for high body count. Remember bin Laden in his documents, he was urging his followers to think about derailments in the United States. But there are some problems there. Now, what have they actually tried to do? There have been only 22 attacks on high-speed rail, mainly in Western Europe, where high-speed rail has been in operation for a long time. Generally, the countries with high-speed rail systems are not the countries with major terrorist problems. Most attacks on rail are in India, Pakistan, and in developing countries. Now, where we get some overlap is in France, Russia, and Spain. What have terrorists tried to do? Most of their attacks involved improvised explosive devices. 12 of these attacks, these devices, were bombs placed on tracks or bridges or near the train. 3 attacks involved bombs concealed in the passenger compartment. And this is the big difference between high-speed rail and non-high-speed rail. When terrorists are going after non-high-speed rail targets, they're going for high volumes of high body counts. They put the bombs in the compartments or in the stations. When they have gone after high-speed rail, limited number of events, they have tended to target the rails themselves, although not with great success. Of these 22 attacks, only 2 resulted in fatalities, 5 in one case, 39 in another. That was the Nevsky Express between Moscow and St. Petersburg. So we have basically one incident that drives the numbers. In terms of a comparison between their return on investment, if I can use that terrible term for terrorism, they do better with non-high speed than they do with high speed. Just some quick observations here. I'll just highlight a couple of these. Accident and attack data basically suggests that high-speed rail offers terrorists no operational advantage over non-high speed. Terrorists bent upon slaughter can more easily achieve high body counts attacking crowded subways. Only successful derailments of high-speed trains can theoretically match the results of successful bombings, but those are difficult to do. And to finish up, basically the primary attraction is some symbolic value. One of the things that we think we might see are bombs planted on high-speed rail tracks, not really with a realistic expectation of derailment, but simply as a disruptive or potentially as a means of extortion. Thank you very much.
Thank you, Brian. As I think you could see, Brian deals with a very complex and difficult subject in a way that is very applicable to the audience, and we appreciate that greatly. So, Armin's now going to talk about some of the European and the railcar experience.
Hello, everybody. Good afternoon. I'm excited to be here and honored to be on this panel. A panel of all California residents. So we're all from the great state of California, and we're very excited about what's happening in our state. Thanks for inviting me to be on this panel. I'm going to use more pictures and more kind of a not so grim message, I hope. So let's go. See, this looks pretty cozy, you know, 2 high-speed trains hugging each other, a bunch of stressed drivers on the side. That's how high-speed rail should be. All right, let's see if we get this going. Okay. I'm going to address three areas on this topic of operational integration of high-speed rail. The first one, integrated infrastructure, integrated service. I'm going to use two case studies from overseas to show how integration has been done by design to arrive at integrated infrastructure and integrated service. Secondly, I'm going to look at the importance of standards using two examples yet again. One, what happens when there is no standard, and the second one, what happens with the standard. A common approach can be achieved, and actually a global marketplace can be the result of that. And I'm going to finish up with lessons learned from all of that, from these global experiences, and how that can be used to move the US in the right direction. So here's the two case studies. They're from Germany. The left side basically shows a typical, high-speed rail system. You got major city A, major city D down here. Got intermediate cities in between that have great growth potential with this high-speed system coming. And on the right, you see basically the German rail system, including the high-speed system that's overlaid in the general railroad system. And that's very different from a radial system or, a coastal railroad. This has the full complexity of an actual network. Germany is a polycentric settlement structure, multiple centers, they all have to be connected. Not an easy thing to do, and lots of debate on what to build first and where to put the money, obviously. So case study one is Cologne, Frankfurt. And what I'm going to highlight there is that for high-speed rail, you can use existing, upgraded, and new alignment sections. And it's important to remember when this line was built, 1 hour of runtime was cut out between the two cities compared to the old route along the Rhine River, which has obviously resulted in great ridership on that. Also, the intermediate stations that were built there have really seen a lot of growth. The second case study that I'm going to look at is Nuremberg, Munich, and that is a typical example of integrated service. So, up here you see Cologne main station, the Rhine River crossing, the dome would be right over here. And blue on this here you see is upgraded alignment. So you come out of this station, you use 100-year-old infrastructure to get out where it's densely populated. Then you get down here to to an upgraded area. And upgrades have been stepped up in Europe. When I went to school, 100 miles an hour was kind of, that was what people wanted to achieve. Then it went up to 125. Now we're talking about 145 mile an hour upgraded sections in Europe. Those can be used for high-speed line. And then obviously you can put your money where you're really going to save time, out there where you can build high-speed lines and where you can cut out time between the two cities that you're trying to connect. So you can use existing lines, you can use upgraded lines, and you can build new where it makes sense. And largely that's been talked about as integrated infrastructure. The California High-Speed Rail Authority has coined that theme of blended system, which is exactly the same thing. This is blended system. You utilize existing infrastructure, you build out where it makes sense, and you build new where it works best. Down here, you see the Frankfurt Airport train station, and if you haven't done it, it's a great way to get to Europe and hop on a train right away out of the airport and be at the Dome in Cologne 60 minutes later, walking across the plaza there. And we've talked about this as well, right? It doesn't all have to be in competition all the time. So this is actually a rail operator, the German rail operator, wrapping an entire airplane for advertisement purposes and saying, take the train to the plane. And that's exactly what you can do at Frankfurt. So there, in the air market can then focus on the longer haul flights where they're actually making money, and rail can focus on getting the travelers into the hubs in a very efficient way. So the goal should really be to meet the mobility needs the best way you can and to use the system efficiencies. The second case study here is Nuremberg-Munich, where you see 3 rail services, and you see it's exactly the same spot the picture has been taken at. So all of these services go over the high-speed line. So not only high-speed product has to be on high-speed lines, you can also have other services on there. The goal, in my opinion, should be, if you build high-speed alignments, it's a very expensive proposition. You should really take advantage of it, and you should keep them busy, and you should run as many trains as you can over them and create as much demand as you can. And that can be high-speed trains, or it can be other trains. The investment decision should again be driven by what's best. And that justifies the investment. And this again, California calls that blended operations, and it's the exact same thing as integrated service. Since you couldn't see the pictures nicely, this is high-speed rail coming through at 186 miles an hour. Then you have a regional express that uses the exact same line at 125 miles an hour. This is likely the fastest regional train in Germany. And here you got a commuter train using the same alignment at 90 miles an hour, which is a very fast commuter train. Why they're going so fast is because they have to clear the track for the next high-speed train. So when you look at this technically in a graphic timetable, yeah, there's some pressures there, right? You know, time is money. And so these trains actually have to clear the track pretty quickly. So the flatter the line, the faster the train. The red ones are the ICE trains, the high-speed trains. Then the green ones are those regional trains. And this is likely the fastest regional train, at least to my knowledge. And then you have some commuter trains that use part of this alignment. And you can see how the high-speed trains overtake the regional trains at Ingolstadt. This is a very interesting scenario. So 3 services at different speed levels use the same infrastructure.
All electric.
They're all electric in this case. However, that being said, this example doesn't necessitate that every service runs electric. This could also be done with different modes. So we're briefly at the standards. This takes us to the standards. I'm highlighting this with platform heights. So you see platform heights here in Germany, plenty and a problem. And here are the examples. Why is this guy not wheeling his bike into the train? Well, because he's got to step down into the train. Not very good. And you can see the typical commuter train here with steps up. Not good for boarding, not good for dwell time, not good for elderly people, not good for people with luggage. Big problem. My message here is we should avoid this at all costs. ICE train in Frankfurt, looking halfway okay, typical step in Europe. ICE train in Paris, big gap, big problem. Here it gets even better. TGV arriving in Stuttgart. This lower step is at 680, the platform's at 760, so you can step down and up again, or you can take a wide step across here. And while the elderly person is trying to figure out what to do, there's a big line of people piling up behind that person, certainly not good for dwell time. We should avoid this at all costs. Here is a good example, 680 meets 680. That would be very nice to have. Last example. Here, ICE train in Germany, and then in Copenhagen, same problem again, big step. So for aging population, this is not what we should do. And my call for action is we should avoid this. The genie's not out of the bottle yet. Jeff hasn't built a single platform yet. In my opinion, we should try to get this right. We should avoid these issues at all costs from the get-go, come up with a national standard for the US, avoid discrepant project startups that then cause this. Technology cannot fix this. You cannot fix this. Once the genie's out of the bottle, you cannot fix this. It gets very expensive, very difficult, and at some point the first 2 systems are actually going to meet. Real quick, the second example, those are all the signaling systems you could find in Europe. and it made it very, very hard to do cross-border trains with this. So the European Union went out and said we need one single approach to this, and technology can actually fix this, although it's certainly not cheap. And what resulted from that is the ETCS signaling system that by mandate is to be applied by all European railroads. And since the TSI is actually a document that can be downloaded from the internet, a whole lot of other people have taken advantage of it, and you can see that this idea of a European standard is now becoming slowly but surely a global standard and is being used in many countries around the world because it makes sense and it has created a marketplace. So, lessons learned for the US. Great things are actually happening here, I would say. We've made great progress in the clarity of what goes and what doesn't go. Back in the Florida high-speed times, we really didn't know what would be approved and what wouldn't. Now we know. There's a number of things that have been clarified here. I'm not going to go through all these. Other things still to be addressed, in my opinion. Platform height is one of my pet peeves because I think this could be a very good story or it could become a very problematic one. Signaling is the next one. Please, 1 voltage going forward would help. Coupler heights for dead tows would be nice to be at the same height going forward. We should avoid the mistakes made elsewhere. We have learned those lessons, and we should avoid these different approaches so that we can achieve interoperability. So my recommendation is consolidated high-speed rail standards for North America and take advantage of what's out there. One last slide. This is the example. Amtrak is currently actually following this. This is a very good example, and Siemens is extremely happy to be able to support Amtrak on this path to better service in the Northeast Corridor. They're buying 70 new locomotives, and they're based on global experience, service-proven technology, and ensuring that they're in compliance with the US requirements, and designed in close cooperation with Amtrak. And I think this is a very good example, so you can tie into what has worked elsewhere, and you can apply it to the US market. This will result in a more reliable, more energy efficient, and more maintenance-friendly locomotive, and you'll see the first one showing up in fall of this year here in the Northeast Corridor. Similar to this, we're all hopeful that when the Acela 2 train set procurement comes out, that a similar approach will be followed, taking into consideration the global experience that the manufacturers have and the service-proven equipment that runs elsewhere on the planet, and then adapt that to the US requirements. Thank you very much.
Thank you, Armin. I'd invite people, if you have questions, to come up to the mic, and while we're waiting, Armin, one thing on your points. Could you talk a little bit about how to address concerns about balancing the importance of compatibility or uniformity with the desire to maintain as much competition as possible, and how to strike that balance, or to what degree that's a concern?
Yes.
Yeah.
Yes, if it's too prescriptive, then it might become a problem for competition. The way I would recommend to look at this is to basically survey the global products that are out there and see where there are commonalities, and then use that to keep the competition as wide as possible, but ensure that it's going to work in the long run in a system approach, and to avoid that two systems start completely differently, because at some point they're actually going to meet, likely not in anybody's lifetime here, but they will, and then when you have the same problems like I showed in the pictures, that's going to be very, very problematic.
Okay, thank you. Okay.
Ross Capon, National Association of Railroad Passengers. Stan, you said that the availability of information is a significant indicator of whether people will make transfers or perhaps even use public transportation. One of our board members got a foundation grant to put intermodal station monitors in a number of stations in Michigan, Illinois. And the first one went up in Kalamazoo on Friday. And this is a monitor where intercity bus and I believe local bus and Amtrak are all on the same monitor, so you don't have to go scurrying around to find each of the stovepipes. Now, neither the association nor our insurance company is interested in us becoming the National Association of Intermodal Station Monitors. So I'm hopeful that people in the business will observe the monitors we put up, and they will start to sprout all over the place. Thank you.
Thank you, Ross. I'm certainly interested in that example. That's a terrific idea. I think there must be a U.S. congressional law against that they're violating.
Art?
Art Gazzetti with APTA. There's been some references to California and the concept of blending. It seemed when that concept came up, it helped the project move forward in a better way, in a more cost-effective way. I'm wondering, when we think about the corridors across the country, if that concept seems so logical, you know, where it makes sense to use the existing infrastructure, use it. Where you really can't, for whatever reason, build a different structure. And every corridor should be blended. Now, I say that, you know, not knowing what I'm talking about to a full degree as a policy guy and an advocate and not a design person or an engineer. But it seems to me that blending is the way to do it everywhere, and I just invite comments on that.
Let me, I'll start with that. I think the approach that we've taken in California was developed for a number of different reasons, and I think it was against a backdrop of the way the system had been seen for a number of years in its early planning and design as a very pure system, if you will. You know, 100% dedicated lines. And I think there was a prevailing view among many involved in the project that that was the only way to ensure that you had, in fact, world-class, true high-speed rail. Two things have happened over the course of the last year, in particular on that front. One, different people have come in and taken a different view, saying that there may be different ways of accomplishing things. And Armin's, I think, the pictures in Germany were really instructive of showing 3 different types of service operating over the same infrastructure. Obviously, again, there's some complications that come with that, but it can be done, and it makes it more economical, more useful. The other issue driving the decision was practicality of looking for ways to more, to basically bring down the price of delivering the system and show a greater return on the investment for it. So I think it was a combination of practicality, common sense, but also a better understanding of what is possible under the system, and that you don't have to compromise the high-speed operations by allowing other kinds of operations on it. And I'll just say, for the California program, we've seen, I'm not sure I could say it's a 180-degree shift, but we've seen a massive shift in the view of the regional transportation partners toward the high-speed program now that we have adopted a blended approach where everyone now sees a common benefit. And it's worth noting that, in fact, the first electric high-speed line in California will be a shared corridor, the Caltrain corridor, between San Francisco and San Jose, which was a complete change in approach to what was being planned previously. But Armin or Stan, do you have anything to?
Well, I think, Art, from a policy point of view, we would all agree with you. And I think we have to remember that in the U.S., other than in some isolated places, passenger trains are sharing rights-of-way with freight trains. And some of the complexities of what a blended system is and how we develop incremental approaches to improved intercity service have to take into account the interests of both the freight railroad and the passenger sponsor. And that is a complication, but generally, I think you're right on.
I think it lies in every project, by definition, is unique. And you might find projects where all new is the right way to go. In many cases, you're trying to get to very established transportation hubs that are already there, and the all-new option is simply either not affordable or politically suicidal. So it's just a smart way to use existing infrastructure and upgrade where possible and build where it makes sense.
Mort?
Yeah, just following up on that, I certainly agree. It's very sensible. Does introduce some operational complexities. And what I'd be interested in some comment on is how you deal with the institutional issues of different services, perhaps different sponsors, different technologies, balancing out to work to everybody's benefit.
Stan, do you want to take the first shot, or I can? Or?
Well, I'm reminded of some of the presentations earlier today where the FRA talked about 32 states coming up with arrangements and contracts with the Class 1 railroads and trying to deal with that part of the institutional issues. And of course, on the Northeast Corridor, which is our #1 example, we have NJ Transit and SEPTA and Conrail and Amtrak, and the institutional issues there are dealt with through arrangements, contracts, monthly meetings, and a lot of prayer.
Another way to maybe look at this is clearly track access charges. Obviously, you have to take into consideration what the revenue potential is for any one of these train classes, and a track access charge for one of these commuter trains clearly should be significantly lower than for the high-speed trail coming through. There's technical reasons for this, but there's obviously also commercial reasons for that.
Brian, let me ask you, on the security side, given that high-speed rail is new to the U.S. and there aren't, we don't have we're always full upon, the track record to work off of. Who do we look to for standardization, for, the right way to deal with issues, and trying, unlike the case you noted with aviation, hopefully being ahead of the curve instead of responding to it?
Well, I think that's what we're trying to do now in terms of looking at some of these systems, especially systems where there have been incidents, and see how, or where there have been perceived threats, and see what kind of practices they have developed. That would include, of course, the system in France. It would include the system in Spain. It would include the system in Germany. So the European system. Now, we don't have, fortunately for society, unfortunately for research, we don't have a rich history here. We have a very, very tiny history. But circumstances, events have obliged some of these countries to put into place security measures. One lesson that I think does come out of this, and which is a design thing, is that circumstances change over time. What we're building is going to be in place for many, many years. It's going to be in place for decades. Circumstances can change, which will oblige systems where security may not have been a paramount issue to take security up a notch. A question is, can we, at the design stage, anticipate the possibility, not necessarily implement the measure, but anticipate a possibility so that if we were to have to take security up a notch to where some of these others have gone, it would not be impossible to do because of the inherent structure. I mean, the comparison on aviation's side, which you'll be familiar with, Jeff, is when we talked about deploying explosives detection systems at airports, where all of the conveyor systems in the tunnels simply were not of a size, of a capacity that enabled us to do it. So we ended up stacking these explosives detection machines, which were great big machines, into the terminals as opposed to into luggage, where it would have been the smartest place to put it. can we think of things like that? If the need should arise to segregate passengers or to take, say, to introduce a measure, can we do it? That is not advocacy of saying, let's catalog all of the existing security measures at all of the systems worldwide and then take that as our standard and say, well, France does this, Germany does that, Spain does that, Japan does that, therefore we have to do all of these things. That would be ruinous.
Well, following up on that point, Brian, I think also if I took your points right, you would say that while some level of security will be needed and should be developed, it's dropping the airport model on a high-speed rail system would not be appropriate or necessary. Is that fair?
No, first of all, I think what we're learning over time is that not only is the aviation security model not applicable to high-speed rail, it's not applicable to commercial aviation. I mean, we are at a level now where an increasing number of security measures, growing passenger loads are just basically obliging us not to tweak the system, but to fundamentally review our aviation security strategy. So it's not working there. Heaven forbid we should take that model and say, yes, we're going to put it into an environment where the volumes will be even higher and the pressures for speed will be even greater. That clearly is not an appropriate model for us. The other point I would make here very, very quickly is that we always have to, when we think about these things, we tend to think about security by transportation system or by other categories of targets exclusively in the context of that particular system. What we really have to look at is a global threat picture and think about a net security benefit. If I can design a system that will protect the hell out of any category of targets, it'll be disruptive, it will be expensive, but it will work. But if the net benefit of that is that I have simply caused terrorists the inconvenience of driving another 2 blocks to another equally or vulnerable target, I have no net security benefit. So I think we have to start with the question that why would we impose massive security measures on high-speed rail when our historical evidence says the easier target for the terrorists, the greater return on the investment, the higher body counts come from setting off very small quantities of explosives in crowded subway stations. So I've got to come up with a reason for making the investment in one that gives me a net benefit. And if I don't have that, then I haven't succeeded really in making the country safer. Now.
Very good. Thank you. Armin, let me ask one last thing to you. I didn't notice a disclaimer on yours saying your views are not necessarily representative of Siemens as a company or anything else, but I would ask the views on compatibility, uniformity, the call for standards, would you say that's a view consistently held among your counterpart companies, other suppliers in the industry around the world?
That would be a great exercise to find out. Maybe a consulting firm can go and quiz everybody. I don't have a very good overview over this. This is mostly, from observation and looking at the different systems and what works well and what does work not so well, and where global high-speed rail is kind of being dialed in. There's many things that where there is a quasi-standard that has developed by accident, and that's good. And for the United States, I would like to see that we don't leave it up to coincidence, that we actually plan it in a way that it works from the get-go and it works for a North American system.
Great, thank you. Well, thank you all. I want to make one commitment to this audience and to the panel that as we move forward with the California program, and Brian, on your topic, my hope and my pledge is that no one will have to take their shoes off to come on any of our trains. So, that'll be one of our performance criteria. So